So the gradient interacts in a particular way with level sets of a function. So the level sets of a function, if you remember, level curves or level surface, they tell us all the places where the function was equal to one fixed value. So if I draw the level curve for where a function is equal to 1, that tells me all the places where the function is equal to the fixed value 1. It doesn't change on that level curve. And so the gradient always points perpendicular to those. The gradient always points in the direction of fastest increase, where the level sets always stay the same. So here at left, here's the function f of x, y is equal to x squared plus y squared, and its gradient is just the list of partial derivatives, 2x comma 2y. And depending on where we are inside two-dimensional space, we get a different gradient. If we're at the origin, then the gradient vector is 0, 0. It tells us that no matter which direction we go, the function is actually increasing pretty slowly. If we go to the position 1, 0 at the right, then the gradient vector is going to be the vector 2, 2. It points in this direction. It points where the function is increasing the fastest by going straight to the right. Whereas if we wanted to slow down and get cooler, we should go straight to the left. And you can see that it's perpendicular to the level curve that tells us where the function is identically equal to 1. Similarly, if we were to go out to the position 1, 1, which is right here, the gradient vector at that position is 2, 2. And it looks instead kind of like this. It still points perpendicularly to the level curve, and it points in the direction of fastest increase. With this function, the fastest way to get warmer is always going to be to run straight away from the origin. Here's another example of a function f of x, y is x times y, which has slightly different level sets. And if we take the gradient vector, we get y comma x. So depending on where we are, we're going to get a slightly different picture of where we should go if we want to increase temperature. So for example, if we're at the position 1, 0, the gradient vector is going to be 0, 1. It points straight up in the vertical direction. The fastest way to increase temperature at this spot is going to be to go straight upwards. If we're at 0, 1, we get a gradient vector which is 1, 0. It points straight to the right. If we're at position 1, 1, we get a gradient vector equal to 1, 1 again. It points like this. And as we go through space and draw different gradient vectors, they tell us a story about where we should go to increase our temperature as fast as possible, always straight perpendicular to the level curves, and always pointing in the direction of fastest increase, like so.